Hello, mathematicians. I hope you guys are doing well, and welcome to a new lesson. Welcome to another lesson. Today, we're going to be talking about the volume of prisms, cylinders, pyramids, and cones. We're going to be looking at how to find the volume of those shapes. Let's start with our objective. I can use given information and formulas to find the volume of prisms, cylinders, pyramids, and cones. So let's start this lesson by finding a definition for volume. How do we define volume? What that means? Well, volume is the amount of space a shape takes in three dimensions. So if you recall from our last couple of lessons ago, area is defined as the amount of space that a shape takes in a flat two-dimensional plane. Volume is the three-dimensional counterpart to that. Volume is how much space a 3D shape takes in 3D space. So every shape on your screen here is taking up a certain amount of volume because it takes up a certain amount of space. So now that we know what volume means, let's take a look at how to find it. We're going to start by finding the volume of prisms and cylinders. So when we find the volume of prisms and cylinders, remember these two shapes are very similar. They have similar properties. They look alike. They look kind of the same. You're going to find that their formulas are also kind of the same. And the way that we can derive these formulas is also kind of the same. What I want you to think about when we find the volume of a prism or a cylinder, imagine that you have the base of your prism or your cylinder. In this case, I have a triangle as my base, so I know I'm going to end up with a triangular prism. Now, to build this prism, we know that this triangle right here doesn't have any volume at all. This is a two-dimensional figure. But as we stack more and more of these same triangles on top of each other, we start to get some height here. And if we keep on stacking, eventually we're going to end up with a triangular prism where the base is still down here, but now we do have some height to this. We can do the same thing with a circle. If I go down here, let me finish coloring this in. If I go down here and I start with a circle and I stack congruent circles right on top of that, and I keep on stacking them, eventually I'm going to end up with a cylinder where my base is a circle down here. And again, this cylinder is also going to have some height now. It's going to be some dimension tall. For a real life perspective of this, let's turn to Mr. Garcia and see what he has to say. Hey guys, so like Mr. G was saying, I have here a sheet of paper, right? It's a two-dimensional shape because there is no height, there's no depth, just a flat sheet of paper that exists in a two-dimensional plane. It only has length and width. Now, say I take this sheet of paper and I put another sheet of paper just like it on top of it. Well, it's still pretty flat, but you do notice that it's a little bit thicker. And as I put more sheets of paper over this, now it's getting a little more thicker, and I can keep going, putting more sheets of paper until I end up with this. Now I have a rectangular prism, right? It's a 3D shape. It's not just a rectangle anymore. Now it's a whole prism. So what I'm trying to show you here is that if I have a sheet like this, which is only area, right? This is only occupying 2D space area. But as I stack more and more of this same area on top of each other, eventually I can end up with a three-dimensional shape that takes up volume now. Make sense? So we're going to see how we use this when we go back to Mr. G. Thank you, Mr. Garcia, for that wonderful insight. It's always appreciated. So with that explanation then, how can we come up with a formula for volume? Let's take a look. This formula is telling us that to find the volume of a prism, that's equal to this capital B times H. Now, you've seen a lowercase b before that represents the base of a triangle, of a rectangle, of a trapezoid. This capital B represents the area of the base of my prism. So make sure you understand that. This capital B is not just a base. You're not going to have just some numbers there. You have to find that capital B first, that area of the base. So in this case, since I have a triangular prism, I'm going to need to find the area of this triangle at the bottom. The H here doesn't represent the height of the triangle. It represents the height of the prism. Now, when we talked about the height of a prism, we're talking about the distance between one base of the prism and the other base of the prism. Sometimes that'll be vertically, like it is here, but not always. So we have to be very careful here that we know the height is between the bases, the distance between each base. Same thing can happen for the cylinder. We have a height, and that refers to the height, the distance between bases of my cylinder. Now again, we can find the formula by finding the area of the base multiplied by the height. So that's what this part here is. Remember that the area of a circle is pi r squared. So this is also the area of the base, except that this time my base is a circle. And we know the radius will be the distance from the center of the circle to the edge of the circle. And we can use that in our formula to find the volume of the cylinder. Let's take a look at two examples, one of each, so that we get an idea of what these problems will look like. Take a look at this one. Ruben's new Apple Watch came in a box, which is in the shape of an octagonal prism. What is the volume of this box? So when I know I need to find the volume of a prism, I know that I need to start with the formula for volume of a prism. So here I'm going to be finding two things. I'm going to be finding the area of my base, and I'm going to be finding the height of my prism. Now take a look at this prism though, and let's highlight the base so that we know where that's at. If we see here, we have a rectangular shape all around here. So these must be the lateral faces. So our base is here in the front. Our base is an octagon. We know that because we can count the number of sides, and it tells us in the question that it's an octagonal prism. So since our base is an octagon, we're going to have to find the area of this octagon first. Now, since this is a regular octagon, I know that every side is congruent. We're going to be using our formula for area of an octagon. Remember, we have those formula sheets in our Google Classroom. Go under classwork, look under the resources, and you'll find the formula sheet for area and for volume. Use those because we're going to need to still calculate area here. Now, area of a regular polygon is the opossum times the perimeter divided by 2. And since we don't have the perimeter given straight out, we can also use the opossum times the side length times the number of sides divided by 2. Now we can see that the opossum of our regular polygon here is 5.5 centimeters. So let's plug that into our formula. I'm putting it in parentheses so we know we need to multiply. The side length here, notice it's not 11, because 11 is not on the polygon itself. 11 is on this lateral face. So we're not going to use the 11 for this formula here. For the side length, we're going to be using 2.3 centimeters. So let's write that in. 2.3. And then we know the number of sides because it's an octagon. The number of sides will be 8. And we divide all that by 2. So let's go to our calculator. I want to type in our formula. We're going to set up our fraction, and we have on the top 5.5 times 2.3 times 8 divided by 2. That gives us 50.6. So 50.6 is the area of our base. Now we need to find the height of our prism, not of the base, the height of the prism. And that's where the 11 centimeters is going to come in. Remember that the height of a prism is the distance between bases. So I have one base here in the front, and I know my second base is over here in the back. So the height that I want is the distance between those two bases, which happens to be this 11 here. So here is the height that we're going to be using in our formula. So now I know the area of my base. I know the height of the prism. Our formula for volume tells us to multiply them together. So we have 50.6 times 11. If we go back to our calculator, 50.6 times 11 gives us 556.6. So the volume here, 556.6. Our units here is centimeters. So for volume, we're going to use centimeters cubed. When we talk about volume, our units are cubed. So you're going to look at what units we're using here, and we put a 3 on the top to represent that they're to the power of 3. In other words, they are cubed. So that's our answer. Some takeaways here. The hardest part here is calculating the capital B, because that is never the same for a shape. It depends on what shape your base is. So be very careful calculating that capital B. Use the area formula that corresponds with what shape your base is. So if your base is a triangle, this must be the area of a triangle. If your base is a rectangle, this will be the area of a rectangle. If your base is a trapezoid, this will be the area of a trapezoid. The height is always the distance between bases. So if your bases are front and backwards like this, and your height is horizontal. But for example, here, your bases are stacked one on top of the other, then your height is in the vertical direction. So always be aware of which direction that height will be. Okay, let's move on to the next example. A company wants to know how much space is inside the can shown below. Find the volume of the can. Since we're looking at a can, we know that this can is a cylindrical shape. So we're going to be using the volume of a cylinder here. Let's write out our formula for volume of a cylinder. And we know that's going to be pi r squared times h. And we know that r represents the radius and h represents the height of the cylinder, the distance between our circular bases. So there's two things here that we're finding as well. We're finding the radius and we're finding the height of the cylinder. So we can see that the radius is 2.5 inches. It's given to us here. So we know that r will be 2.5. And the height is also given to us. It's 6 inches. So we have that. So now let's plug it into our formula for volume. So we're going to have pi parentheses, so we know we're multiplying, and inside is going to go the radius. So you have 2.5 squared, and then times, I'm going to put another set of parentheses, 6. So let's go over to the calculator and plug it in. So we have pi parentheses 2.5 squared, close parentheses. And that's the wrong one. Open parentheses. And 6. So pi times 2.5 squared times 6. And we get 117.81. Notice that the square is inside the parentheses here, but I wrote it on the outside here. It doesn't make a difference because this square is only applying to the radius. This square is not used for the pi. It's not used for the height. This square is only for the radius. So you're only squaring the radius, which is why if I put it inside the parentheses here, it doesn't change my answer. Or if I put it on the outside, and I'll show you guys. If I put it on the outside, it's still only applying to the 2.5. So I still get the same answer, 117.81. Just something for you guys to keep in mind. So my volume, 0.81. Our unit here is inches, so our volume will be in inches cubed. I'll put this as a 1. So 117.81 inches cubed is our volume. So let's move on and talk about now the volume of pyramids and cones. So when we think of a pyramid, we still have a capital B, we still have a height. So it's very similar to a prism, except now we're also multiplying it by 1/3. Or in other words, we're dividing by 3. B, capital B, represents the area of the base, and H represents the altitude of the pyramid. So sometimes you will see problems where they give you this length. This is not the height. This is called the slant height of the pyramid, and it also applies to cones. You will never use this for volume. If you have this given, you need to ignore it because we're not using this for volume. This is actually used for surface area, which we're not going to talk about now. But what you're looking for is the height, the altitude from the apex to the base, and is perpendicular to the plane of the base. Let's take a look at a cone now. So for a cone, the formula is the same as a pyramid actually, but because the base is a circle, we have that pi r squared again. So remember that this is your capital B because that's the area of a circle. In other words, the area of the base. And we still multiply by the height. And again, the height here is from the apex of the cone to the base of the cone, and it's perpendicular to the base. If you're given this line here, this is not your height, this is the slant height, and you're not going to use this for volume. So ignore this if you're finding volume. R represents the radius of the base, which is the radius of the circle, and H again represents the altitude of the cone. Let's take a look at 2 examples, one of each. Miss Cattey is designing a pyramid for her birdies to play around in. If you saw her Fun Friday video, then you know about her birds. So she's building a pyramid-shaped cage for them to play in. She's using the dimensions shown below. How much space will the birds have to play around in? That's asking you for volume. It's asking you for the amount of space. Anytime it says that, it's asking for volume. So let's take a look at this. So I'm going to start by writing down the formula for volume of a pyramid. If I look back, I know that's 1/3 times base times height. Area of base times height. So let's copy it over here. 1/3 times area of base times height. Again, I'm going to be looking for each of these. So I'm going to start with the area of the base. Now, first, I need to identify what my base is. So let me get my highlighter. If I see the apex of my pyramid, I also see the line that represents the altitude. And it seems to touch this triangle here at the bottom. So this must be my base. So let's highlight that. So here's my base. And I need to find the area of this base. It's a triangular shape, so I know I'm going to be using the area of a triangle. So let's write that formula down. The area of a triangle is the base of the triangle times the height of the triangle divided by 2. Now notice that I'm being very specific when I say my B and H here. Base of the triangle and height of the triangle. This can get a little confusing because you have H's in both of these formulas and you have B's in both of these formulas. Remember that the capital B is an area. So this represents the area of a 2D shape. My triangle down here is a 2D shape. So the base and height here, lowercase b, and height of triangle is using the dimensions of only the triangle here at the bottom. So the base of the triangle base here is 30 inches. And the height of the triangular base here is 28 inches. And I know that because I can see that these two lines are perpendicular. So these two must be my base and height for the triangle. Make sure that if you get confused with that, you reach out to one of us, because that's a part where a lot of you guys will get confused. Be very careful with that. So let's plug it into our formula for the area of the base. The base of the triangle is 30 inches. The height of the triangle is 28 inches. And I know I'm going to be dividing this by 2. So let's find out what that gives us. We're going to clear this, set up a fraction. We have 30 times 28. And then on the bottom, I divide by 2. That gives me 420. So my area for the triangle down here is 420. Now let's find the height. And again, this height is talking about the height of the pyramid. Since I'm using the height up here, this is for volume. It refers to the height of my pyramid, 44. This is not the height of the base anymore. Now, this is the height of the pyramid. So let's plug these numbers into the formula for volume so we can find what this volume is. We have V equals 1/3, and I have the area of my base, which was 420. I have the height of the pyramid, which was 44. Now I'm going to plug them in and see what I get. Summon my calculator. So I'm going to start with my fraction. And I have 1/3. Then I have times 420 times 44. And so that gives me 6,160. 6,160. Our units here are inches. So for volume, we have cubic inches or inches cubed. Yeah, and this is going to be confusing for some of you guys because of those bases and those heights. Remember that we're talking about two different bases, and two different heights for two different shapes. The capital B refers to the area of the base. So think of that individually separate from everything else. First, I'm only going to find the area of that base. So I use the base and the height of the base of the pyramid. I know I'm using base a lot, but that's what it is, basically. So just keep those in mind. Just keep that in mind. Separate them, find the area of the base first, and keep that only in the capital B. And once you have that done, then find the height of the pyramid. Now you're not using the height of your base. Now you're using the height of the pyramid. Then just multiply them. Multiply that by 1/3, and you got your volume. Let's take a look at an example of the cone now. The company that makes those little cone-shaped cups has asked you to evaluate their new product. You want to start by finding out if the cups hold enough water to be cost-effective. Find out how much water a cup can hold using the dimensions given. So if we take a look at our cone, we see our dimensions, and we need to find out how much water this little cup can hold, which means we're looking for the volume. We're looking for how much space we can fit inside this cone. So let's start by writing down our formula for volume. We have 1/3 times pi times radius squared times the height of the cone. So let's start by finding this information. We need the radius and we need the height. So our radius, we can find that from the diagram. We know that the radius has to be from the center of the circle to the edge of the circle. So we're going to start there. We have that, and we see that that's 4 centimeters. So we can write 4 here. And the height of our cone, we have 2 numbers here. Which one's it going to be? If you guess 6, then you are correct. Because remember, this 7.2 right here is the slant height, and we're not using that. We're only using the height that goes from the apex down to the base, and it's perpendicular to the base. So we have our radius, we have our height. Let's plug those into our formula and see what we get. So we have volume equals 1/3 pi times our radius, which is 4 squared, times the height of the cone, which is 6. And if we plug that into our calculator, we have 1/3 pi. I don't want the pi's there. I want it next to the fraction. So be careful with that. If you press pi and it ends up here at the bottom of your fraction, you don't want that. Put it on the top here, on the side of the fraction. Then times 4 squared times 6. That gives us 100.53. So our volume here for the cone, 100.53. We're using centimeters. So we have for volume cubic centimeters or centimeters cubed. And that's the volume. So with this information now that we've gone over this lesson, you should be able to handle the assignment. Remember to reach out to us if you have any questions. Make sure that you mark as done, because a lot of you guys are still forgetting. to mark as done when you finish the Google form. When you submit that Google form, make sure you mark the assignment as done. All right? So this has been Mr. Garcia. I hope you guys had a great time here. I hope you understood the lesson. If you have questions, please reach out to us. And I'll see you guys next time. Have a great day. Make positive choices.